For centuries, texts that no one could read have been found across the world. Clay tablets with mysterious markings, stone slabs covered in symbols unlike any known alphabet, and scrolls written in languages that died thousands of years ago and left no descendants. Generations of linguists, historians, and cryptographers struggled over these texts and suffered defeat. The human brain, for all its power, could not cope. There was too little data, too many options, and the key to the solution was buried too deep in the past. And then came neural networks, machines capable of processing millions of options per second, finding patterns invisible to the human eye, and offering solutions that no scientist would have thought of in a lifetime. Over the last 10 years, artificial intelligence has made breakthroughs in deciphering ancient texts that seemed hopeless. 6 stories of how a machine read what a human could not. The first story, and perhaps the most impressive, is connected with the charred scrolls from Herculaneum. In the year 79, Anno Domini, the eruption of Vesuvius, destroyed not only Pompeii, but also the neighboring city of Herculaneum. A glowing stream of gas and ash, a pyroclastic wave, covered the city in minutes, killing all residents and burying buildings under a 20-meter layer of volcanic material. But unlike Pompeii, where buildings were covered with ash, in Herculaneum, the temperature of the flow was so high that wooden objects did not burn but charred, turning into fragile black carbon that preserved its shape. In the 18th century, when the excavations of Herculaneum began, workers discovered a luxurious villa, the so-called Villa of the Papyri, which contained the only surviving library of the ancient world. About 1,000 scrolls made of papyrus, charred to blackness, pressed into lumps, as fragile as dry leaves. Each scroll is a potentially lost work of Greek or Roman literature, philosophy, or science. Texts that existed in a single copy and were considered lost forever. The problem was that it was impossible to read them. The scrolls were so fragile that any attempt to unroll them ended in catastrophe. The papyrus crumbled into dust, taking the text with it. For 300 years, scientists tried everything: chemical reagents, humidity, heat, mechanical devices. A few scrolls were partially unrolled, revealing fragments of philosophical texts in the Greek language, but most remained unreadable black lumps. In 2023, a miracle happened. A group of researchers, physicists, programmers, and papyrologists united in the Vesuvius Challenge project. The idea was crazy: to scan the scrolls with an X-ray tomograph, like a doctor scans a patient's body, and obtain a 3-dimensional image of the internal structure without unrolling them. The problem was that the ink the ancient Greeks wrote with was carbon-based and black, and the charred papyrus was also carbon and black. On the X-ray image, the ink and the papyrus looked the same, as if you were trying to read black text on black paper. The human eye saw no difference, but the neural network did. Researchers trained a machine learning algorithm on those few fragments where text was visible. They taught it to distinguish microscopic structural differences between the surface of the papyrus with ink and without it. The differences were tiny, a few microns of difference in relief, unnoticeable to any instrument except a synchrotron tomograph with a resolution of a single micron. The neural network processed terabytes of data and began to see letters. Greek letters on the surface of a scroll that had not been unrolled. Text that no human had read for 2,000 years. The first read word was porphyros, purple in ancient Greek. One word, and the hall in which the result was announced exploded with applause because one word meant that the method works, that the entire scroll can be read, that all 1,800 scrolls can be read, that the lost texts of antiquity, works we considered lost forever, might still exist, sealed in charred carbon, and the neural network is capable of extracting them. By the beginning of 2024, several columns of text had been read. It turned out that the scroll contains a philosophical treatise of the Epicurean school, a discussion on pleasure, taste, and the enjoyment of food. The author is presumably Philodemus of Gadara, a philosopher of the 1st century before Christ, whose works were known only from fragments. This is not Aristotle or Plato, but it is a text the world has not seen for 2 millennia, and this is only the beginning. More than 1,700 scrolls are waiting their turn. Among them could be lost tragedies of Sophocles, unknown dialogues of Aristotle, lost books of Titus Livius, or none of the above. We will not know until the neural network reads them all. The scale of the possible find is hard to overestimate. Of all ancient Greek literature, according to various estimates, less than 1% has reached us. 99% of what the Greeks and Romans wrote is lost. Of 123 plays by Sophocles, 7 have survived. Of approximately 90 plays by Aeschylus, also 7. Everything else perished in library fires, wars, invasions, and simply from time. The library of the Villa of the Papyri, the only surviving library of the ancient world, can return part of these losses to us, or it cannot. We do not yet know what is in these scrolls. Perhaps they are duplicates of already known texts, perhaps philosophical treatises interesting only to specialists. Or perhaps one line of Sappho, one scene from a lost tragedy, one thought that will overturn our understanding of antiquity. The neural network does not distinguish between the great and the banal. It simply reads. And we will still be the ones to decide what is important. The organizers of the Vesuvius Challenge announced a prize of $700,000 for the first read lines and received more than 1,600 applications from programmers, physicists, and enthusiasts from all over the world. The winners were students from Nebraska and 2 researchers from Switzerland and Egypt. They worked independently of each other and arrived at the same results. This confirmed the reliability of the method. 3 people, 3 approaches, the same text. The second story takes us back 4,000 years to one of the oldest undeciphered writing systems in the world. Proto-Elamite writing was used in the territory of modern Iran around the 3rd millennium before Christ, even before the emergence of the Persian Empire, before Cyrus the Great, before Zoroastrianism. About 1,600 tablets with Proto-Elamite signs were found during excavations in Susa and other ancient cities, and for more than 100 years, no one could read them. The script was not connected to any known language, had no bilingual inscription that would allow establishing a correspondence, and contained more than 1,000 unique signs, most of which appeared only a few times. In 2020, a group of researchers from Oxford and several technical universities applied cluster analysis algorithms and neural networks to the Proto-Elamite tablets. The idea was as follows. Even if we do not know what each sign means, we can analyze the structure of the texts, which signs appear nearby, in what order, with what frequency, and based on these patterns determine which signs are numbers, which are names, and which are names of goods. Most Proto-Elamite tablets are economic records, accounting for grain, livestock, oil. This is not poetry or philosophy. This is Bronze Age accounting. And accounting, unlike literature, obeys strict rules. Numbers stand in certain positions. Units of measurement in others, names in third ones. The neural network processed all 1,600 tablets and identified groups of signs that with high probability designated numerals and units of measurement. This allowed for partial reading of the tablets, not in the sense of translation into a modern language, but in the sense of understanding the structure. Here a quantity is recorded, here the name of a product, here the name of an official. Full decipherment of the Proto-Elamite script is still far off, but for the first time in 100 years, scientists can say they understand the logic of the text, and this is the achievement of machine learning. The third story is one of the most beautiful in the history of linguistics. In 1908, Italian archaeologists digging on the island of Crete found a clay disc about 16 centimeters in diameter, covered on both sides with a spiral of mysterious symbols. The Phaistos disc, named after the place of find, the palace in Paistos, became one of the most famous and most mysterious archaeological finds of the 20th century. 242 signs, 45 unique symbols, and not a single clue to their meaning. The Phaistos disc is also intriguing because of how it was made. The symbols were not scratched on the clay. They were pressed in using stamps. Each symbol is a separate stamp pressed into soft clay, like a seal in wax. This makes the Phaistos disc possibly the first sample of printed text in the world, 3,000 years before Gutenberg. If this is so, then somewhere on Crete there existed a set of stamps, a kind of typographic font of the Bronze Age, which has not reached us. Neural networks attack the Phaistos disc from several sides. Pattern recognition algorithms classified the symbols, revealing patterns in their distribution. Certain signs are more common at the beginning of words, others at the end, others only in pairs. Statistical analysis showed that the text of the disk has a structure characteristic of syllabic writing, a script in which each sign denotes a syllable rather than an individual sound. This narrowed the field of search. If the disk is written in syllabic script, its language must have a certain phonetic structure, and the number of possible candidate languages is sharply reduced. Full decipherment is still not achieved and perhaps will not be. 242 signs is too small a corpus of text for an unambiguous decipherment, but neural networks did what a human could not. They processed all existing hypotheses, and there are more than 20, from Minoan to Etruscan, from Luwian to Semitic, and evaluated the probability of each based on mathematical analysis of the text structure. The most likely candidate turned out to be a language related to Minoan Linear A, another undeciphered script, but one about which we know slightly more than about the symbols of the Phaistos disc. The fourth story transports us to Mesopotamia, the cradle of writing, the land where 5,000 years ago people first began to record their thoughts on clay tablets. Cuneiform, the writing of the ancient Sumerians, Babylonians, and Assyrians, was deciphered back in the 19th century, and today specialists can read cuneiform texts almost fluently. The problem is different. There are too many tablets. According to various estimates, between 500,000 and 1 million cuneiform tablets are kept in the world's museums, and most of them have never been read, not because we cannot, but because we do not have time. Reading one tablet takes an experienced Assyriologist from several hours to several days. At such rates, reading all the tablets would take thousands of years. There are a few hundred specialists in cuneiform in the world, and there are several 100,000 tablets. Mathematics is merciless. In 2023, a group of researchers from the University of Munich and Google DeepMind presented a neural network capable of automatically recognizing cuneiform signs on photographs of tablets and translating them into the English language. The system was trained on a corpus of tens of thousands of already deciphered tablets and achieved an accuracy that the developers estimated as comparable to the work of a beginning Assyriologist, not an expert, a beginner. No, a beginning Assyriologist who works at a speed of thousands of tablets per hour is a revolution. The system has already helped to read several previously unstudied tablets from the collection of the British Museum. Among them were economic records. Again, accounting, lists of workers, calculations of salaries in grain, receipts for oil. Nothing sensational. No, it is precisely such boring texts that make up 90% of the cuneiform corpus. And it is they who tell us more about the daily life of ancient Mesopotamia than any epic. How much grain did a worker receive per day? What was the price of a house? How much did a slave cost? The answers to these questions lie in unread tablets, and the neural network can extract them in hours rather than years. But there is also a more ambitious goal. Among the hundreds of thousands of tablets, there are likely hidden texts that will overturn our understanding of ancient history. Lost myths, unknown laws, diplomatic correspondence between kingdoms we know nothing about. Each unread tablet is a sealed envelope with a letter sent 5,000 years ago. The neural network is the mailman who will finally deliver these letters to the recipients. The fifth story is about a language that was long considered untranslatable. The Rapa Nui script Rongorongo is one of the most mysterious writing systems on Earth. It was used on Easter Island, a tiny piece of land in the middle of the Pacific Ocean, known for its giant stone heads, the Moai. Rongorongo is rows of symbols carved on wooden tablets depicting people, animals, plants, and geometric figures. 26 tablets have survived in the world's museums, and not one of them has been read. The problem of Rongorongo is in its isolation. Easter Island is one of the most remote inhabited places on the planet. The nearest land is the coast of Chile, 3,700 kilometers away. The writing developed in total isolation from the rest of the world. There were no contacts with other civilizations, no borrowings, no bilinguals. When Europeans arrived on the island in the 19th century, they brought diseases and slaveholders with them. Epidemics and the slave trade destroyed most of the population, and along with them, everyone who knew how to read Rongorongo. By the time scientists became interested in the tablets, not a single living person capable of reading them remained. A language locked in 26 pieces of wood and not a single key to the lock. In 2024, researchers applied computer linguistics methods to Rongorongo, which were previously used for the analysis of genetic sequences. The idea, if the text cannot be translated, its structure can at least be determined. Is Rongorongo a real writing system in which symbols convey language, or a mnemonic device like the knotted string script of the Incas, which records ideas rather than words? The neural network analyzed the distribution of symbols, frequency of repetitions, length of words, and structure of sentences. And it concluded that Rongorongo is with high probability a logosyllabic script, a system in which some signs denote entire words and others syllables. This is fundamentally important. It means that Rongorongo is a real writing system, not a set of pictures. And this gives hope for decipherment, even if not tomorrow. The sixth and final story is perhaps the largest in scale. It is connected not with one text and not with one tablet, but with an entire civilization, the Indus Valley Civilization, one of the three great civilizations of the Bronze Age, along with Egypt and Mesopotamia. 5,000 years ago, in the territory of modern Pakistan and northwestern India, there were cities with populations of tens of thousands of people. Mohenjo-Daro, Harappa, Lothal. Cities with sewage systems, public baths, granaries, and standardized bricks. Cities that, in terms of amenities, surpassed everything that existed in Europe up until the Roman Empire. And this civilization left us its writing. About 4,000 inscriptions on seals, tablets, and ceramics. The Indus script, approximately 400 unique signs, is not deciphered. This is the most famous undeciphered script in the world, and the best linguists of the 20th and 21st centuries have struggled over it to no avail. We do not know what language the residents of Mohenjo-Daro spoke. We do not know what is written on their seals. We do not know what they called their cities, their gods, or themselves. An entire civilization, millions of people who lived and died over the course of 1,000 years, and we cannot read a single one of their words. Think about this. We know that the residents of Mohenjo-Daro built straight streets intersecting at right angles 4,000 years before the New York grid. We know that every house had a sewage system 3,000 years before the Roman cloacas. We know they used standardized weights and measures, cubic weights accurate to tenths of a gram. We know they traded with Mesopotamia. Their seals have been found in Sumerian cities, but we do not know what they themselves called all of this. We do not know their myths, their laws, their prayers. The Indus civilization is the most literate of the silent ones. It tells us everything through its architecture, its seals, its sewage system, and tells us nothing because we cannot read its language. Neural networks have been attacking the Indus script since the beginning of the 2010s. A group led by Rajesh Rao from the University of Washington trained algorithms on a corpus of all known Indus inscriptions and analyzed the statistical structure of the texts. The result confirmed what many linguists suspected. The Indus signs convey language, not decorative patterns, not random marks, but structured text with grammar, syntax, and vocabulary. The neural network discovered patterns characteristic of so-called agglutinative languages, languages in which words are formed by attaching suffixes and prefixes to a root. The Dravidian languages of South India, Tamil, Telugu, Kannada, are agglutinative, and some researchers believe the Indus civilization spoke an early Dravidian language. The neural network did not prove this hypothesis, but it gave it quantitative support that did not exist before. The problem is that Indus inscriptions are very short, averaging 5 signs. It is as if only 4,000 fragments of 5 letters each remained of all Russian literature. Kindness, in winter, Tsar, fish. Try to reconstruct the Russian language based on this, and you will understand the scale of the task. The neural network can analyze the structure, but for full decipherment, either a bilingual text or significantly longer inscriptions are needed. So far, neither has been found, but archaeologists continue to dig in the Indus Valley, and every season brings new seals and tablets. Sooner or later, maybe tomorrow, maybe in 100 years, someone will find a long text or a bilingual. And at that moment, the neural network, already trained on the entire existing corpus, will decipher it in hours. The machine is ready. It is waiting for data. 6 stories, 6 ancient messages. The charred scrolls of Herculaneum, silent for 2 millennia under the ash of Vesuvius, and the neural network that saw black letters on a black background. Proto-Elamite tablets that kept their secret for 4,000 years, and an algorithm that found the structure of an accounting book in the chaos of signs. The Phaistos disk, which challenged 100 years of linguistics, and a machine that determined the type of writing from 242 signs. Cuneiform tablets that humanity does not have time to read, and a neural network reading thousands of tablets per hour. Rongo Rongo from Easter Island, locked in 26 wooden boards and a computer that proved it is a real writing system. The Indus civilization, whose language has been silent for 5,000 years, and an algorithm waiting for data to speak on its behalf. Each of these stories is about the boundary between human and machine. A neural network does not understand text. It does not know what purple is, does not feel the beauty of a verse, does not cry over a tragedy. It sees patterns in data, statistical distributions, correlations between symbols. But it is precisely this, the ability to see patterns on a scale inaccessible to the human brain, that makes it indispensable. A human reads text, a machine reads the structure of text. Together they can read what neither of them would read alone. And here is what is amazing. Dead languages are coming back to life. The people who wrote these texts thousands of years ago could not imagine that their words would be read by a machine. They wrote for their contemporaries, for priests, officials, traders who knew their language and could understand them. They did not think about the future. They did not lay a time capsule. They simply recorded their life, their accounts, their prayers, their thoughts. And now, through a millennium of silence, their voices return. Deciphered not by a human, but by a machine that does not understand a single word, but can read everyone. We live in a unique moment. For the first time in history, we have a tool capable of breaking through the wall of silence separating us from ancient civilizations. A neural network is not a magic wand. It will not decipher what is impossible to decipher and will not find what is not there. but it can do in seconds what would take a human years. It can see what the eye does not see. It can hear what has long fallen silent. And every time it extracts words from a charred scroll, a number from a clay tablet, a structure from a stone seal, it brings us closer to people who lived thousands of years ago and wanted only one thing: to be heard.